In this section, we are going to look at the different types of variables that are there in the Solidity programming language. We'll look at how to initialize them and how to add values to them as well. Now, in any programming language if you take, there are two things that are available. One is variables and the other one is functions. Let's look at why these variables, what are these variables, and what are the functions. So, when you create a variable in a programming language, that means in the memory of your application, you are going to create a space. So, let's say this is the entire memory of your application and it has multiple slots like this. When you create a variable, what you're doing is allocating this storage space to a particular variable. Let's say I'm creating something called as A. So this is allocated here, and it means that this storage space can be accessed using this A variable, right? As the name suggests, variables are manipulative, as in you can change the value that is in the variable. For example, in this location, you can share something like 2, right? 2 is an integer which can be stored inside this variable, this particular space. Or let's say you want to change that, right? You can change that and include, let's say, 4. Yeah, so that is how you assign this space, memory space, to a variable name. And when you access what is A, right? What is A? You will be able to get the value that is stored in this space. If it is 4, it returns 4, and in the previous case, it returns 2, right? So this is all about variables initialization and assignment of the values. So there are two steps for variables. One step is the declaration. The first thing that I did was declaration here. I told I need a space in the memory and it should be represented using A. Also, you will give what is the type of thing that you are going to store here. I can store a string which is like a name or an address or anything, or I can store an integer which is numbers 1, 2, 3, 4, anything, right? So I'll declare, okay, I'm going to store an integer called as A in a particular storage space. This will happen automatically, the assignment of storage space to this variable. You don't need to take care of that, but you need to specify the variable type and the name of the variable, right? Then comes in value assignment. Now, in this space, whenever you create or declare a variable, it is going to be empty, or it will take the default value. For integer, the default value is 0 and things, right? Now, assignment means that you will be able to add a value here. In this case, I can say A is equal to 4, which means I'm assigning 4 to this storage space. So that is about the variable name and the value stored inside the variable, right? Next comes functions. Why do you need something called as a function in a programming language? Is to manipulate the variables. So a function, let's say change A, right? Change A can be a function, and this probably might change A is equal to 20, right? Which means what? It is changing the value stored within the storage space from 4 to 20. That's what this function does. Or you can go one more step and say, let's say multiply A, and here you can say A is equal to A star A, which means the value of A called as 4 will be taken 4 into again 4. It will be multiplied and stored in the same position. So 4 cross 4 is 16. This 4 will become 16 after you run this function called as multiply A. So by this, you need to understand that the role of a function is to manipulate the variables, and the role of a variable is to store some data, right? First, we'll look at the variable types that are used in Solidity, and then we'll get on to functions in the next section. So we'll be using Remix IDE extensively throughout this entire Solidity to understand more about this programming language and start creating programs, etc. Now, as you know, Remix IDE has a file explorer where if you want to create a new file, you will go to create new file and let me name this variables.sol. Remember that .sol is the extension used for Solidity programs. Once I start this, any contract using Solidity will start with this statement called as pragma solidity, and then you'll give the version as well. So I'm using the latest version available. You can check that going to the compiler and looking at the latest version, right? So going back to this is how I declare the statement saying I'm going to write a Solidity program. The compiler will only then understand what you're trying to do. So pragma solidity 0.6.11, or let me go to 12, which is the latest version, right? Here you can have it as greater than 0.6.12, not the exact greater than symbol. You need to use the cap symbol. Shift and 6 will give you the cap symbol, which means if you are writing something in 0.5.6 and you are adding the cap symbol, it means anything above 0.5.6, right? So it's not a suggested approach to use this greater than and less than. So I'll just mention the version number explicitly in this pragma solidity statement. Then entering into the contract itself, the first thing you will write is the contract keyword, right? So any contract in Solidity is going to start with this contract keyword. It is a predefined word. It is mandatory to start with this. Then let me have a name for my contract. So let's call it variables because we are going to look at the variables here, or let me call it basics so that we can also add functions into the same contract. So once I do this, I have to open a flower bracket. Flower bracket is the one that you get when you do shift and then the button next to P, right? So this is the flower bracket that you will get, and when you click on enter, there will be a space that opens between the contract. This is the place you will write your variables and functions for the contract itself, right? Okay, now since we know the basic architecture of a contract now, let's look at some of the common variable types used in other programming languages. Some of the common are integers, unsigned integers, which we'll talk about. We'll have characters, we'll have string, we'll have Boolean, we'll have, let's say, bytes, right? And we'll also have something like long integer and then double and then float, and all of these are different types of character or integers, or sorry, variables that are used in other programming languages, right? Now apart from this, there are some advanced variable types like arrays, enum, struct, and also you will have something like mappings that is there in Solidity, right? Mapping can be seen equivalent to this dictionary in Python, right? So this is also a variable type that's available in Solidity. Yeah, and all of these things is what we are going to look at and understand how to declare and add values to these variables, right? Before getting into this, Solidity takes care of all of the variable types required to create a smart contract, but most of these types are not available within Solidity. There is no character, for example. String is there, Boolean we do have, bytes we do have in Solidity, long, double, float, these are not a part of Solidity at all. Of course, you can store decimal numbers that has to be stored within the integers itself. Usually, integers are named as the whole numbers, right? But in this case, since Solidity does not have full support for floating numbers yet or decimal numbers yet, we'll store the decimal numbers in integers itself. And doing calculations, let's say you want to multiply something by 4.4, you will do multiplied by 44 divided by 10. So that is how you will manipulate the floating numbers in Solidity. That's one additional information I wanted to give, right? So let's get into it. And please do remember that we have 4 visibility specifiers: public, private, internal and external, right? So we'll also be adding the visibility specifier for each of the variable that we are creating. Because remember, only if you make it public or external, you'll be able to access it from the outer world, right? So to create an integer, you will do int, that is the keyword for creating an integer. And then you will say, what is the visibility for this particular variable also. So let me call it as public, and then let me create something called as a. So this is the first step towards creating a variable. As I told you, declaration is the one that you need to do, right? You have two options now. One, either assign the value now itself or leave it as default. By default, integers have 0, and that zero will be added to the storage space if you leave it just like that as default. But you can also do something like equal to 4, right? So this can be done with integers, and it will be assigning 4 to the value in integer. Remember that here you cannot add something like a string, because it will say I cannot convert this into a integer. You have named it an integer, but you are showing a string, right? That's not allowed in Solidity. Okay. One thing here is that this is a variable, right? Whenever you look at other programming languages, anything, JavaScript or Python or anything that you take, if you do a is equal to 10 in the next line itself, you can do that. It's allowed in other programming languages. Then you can also do a is equal to 20, a is equal to, let's say, 15, and all of these things. You can keep on changing the value inside a variable just like that within the program itself. And whenever you call what is a at this point, it will return 4. And at the same thing, at this point, it is going to return 10, and so on. Remember, these things are not accepted in Solidity. Not accepted in Solidity, right? Reason for that is that whenever you change a variable, right? Whenever you change something like, let's say, you have owner, okay, owner is equal to Raghu, and you want to change this to, let's say, owner is equal to someone else, let's say John, right? This change in the variable value is going to be a transaction that's going into the blockchain, right? It will be a transaction. Now, transaction includes transaction fees, and if you do this where you change it in the middle of a program, you do not know where to get the transaction fee from. Who will pay the transaction fee to the miner? And that's why these things are not allowed in Solidity, right? So understand this concept that you will not be able to change the variable once it is declared. You can either assign the value to a variable when you are declaring it, or using a function. These are the only two options. You cannot do this a is equal to 10, 20, etc. outside a function, right? That's one thing to understand. Next, you would have noticed that these lines which I wrote now, what is a is equal to 10, etc. These have become gray in color. These are the comment section in Solidity, right? Just like in JavaScript, you can write a comment to explain more about what this program does, right? And this will not be executed by the compiler. You can write whatever you want in the comments, correct? So for single line comments, you can write double slash and then start writing your comments, right? Start writing your comments. I'll be using a lot of comments while I am training this on Solidity, so that when you go through the program again, you have a lot of readability for this program itself. And if you want to give a multi-line comment, you will say star or slash star, and then go to the next line, star slash. Within these two, you can write any number of comments, and everything will be comments. So this is called as a multi-line comment, and this is exactly the same as how we use it in JavaScript. Okay. So that's the concept of integer and the basic understanding of how to manipulate variables in Solidity program. Next, within integers itself, we have a few types, right? If you have gone through int 8 and int 16 int 8 public B, let's say, and then int 16 public C, let's say. All of these things, if you have gone through, you should understand then that these are also integers but confined in the range, right? How does this int 8 work? Is that you'll store 8 bits of data in integer 8. So how do you calculate how much numbers or what is the range of numbers that can be stored in int 8? Is you will do 2 to the power of 8. So this is integer 8. Yeah. And 2 to the power of 8 is equal to 256 numbers. Now remember that integers does not start with 0, right? It has both negative numbers as well as positive numbers. So taking 0 as the midpoint, if you go left 128 digits and right 128 numbers, you will get a range of minus 128 to positive 127. So total will be 256 numbers, and this is the range for your integer 8. Same way, int 16, if you look at, this will have 2 to the power of 16, and this will be somewhat around 64,000 numbers, right? So that will be minus 32,000 something to positive 32,000 something, right? So same way, the maximum possible is integer 256, which is 2 to the power of 256, and it's a very large number, right? Now, looking at this to explain the concept itself, if I declare B, which is an int 8, to let's say 13, which falls under the range of minus 128 to 127, right? Solidity will accept this. But let's say I'm storing 128. This will not be accepted by an int 8 because that is the range it works on. It works only till positive 127, and if you are storing 128, it will not allow. Similarly, on the other hand, it works till negative 128, but if you go to 129, this will not accept it. Right? So why is this compiler constantly looking at my program? Because I have checked this auto compile option. Right? Remember, I suggested you to switch it on, and that will give you instant kind of errors whatever you do. Right? So with that in mind, let me change it to something like 10, let's say. Okay. Same way, C, you cannot store something like 100k. So it is not going to accept that because it doesn't fall in the range, right? So let's store something like 20 in here. Okay, you're telling me int 8, int 16, everything is fine. But what is this only integer? Just integer, right? This just integer represents int 256, right? So the maximum that's possible in integer is integer power 256, right? So this integer means int 256. So you can either name it as int 256 public A, or you can just leave it as integer. Both are the same things according to Solidity, right? So these are the things about integers in general. Now we have understood how to declare an integer, also how to assign value to an integer. Next, we are going to talk about unsigned integers. So what are these unsigned integers? We saw that unsigned integers means that there is no signature, right? Sign for that matter. That's what the name suggests also, right? In a normal integer, in this scenario, we saw that int 8 is from minus 128 to positive 127, which means a normal integer can contain both negative numbers as well as positive numbers. Unsigned integer cannot contain negative numbers. It can only contain, let's say, positive numbers. So it starts from 0. Yeah. And when you do the same thing, like integer 8 is equal to 256 numbers, right? So we went 128 numbers on the left and 128 numbers on the positive side. So instead of that, in unsigned integer 8, you will have 256 numbers, and the range will be from 0 to 255, right? Because there cannot be a negative number in unsigned integer. Unsigned means there is no negative signature. Simple as that, right? So if I want to create that, uint 8 public, let's say d is equal to -1. This is not gonna accept this because it's not a unsigned integer that I'm creating. But I can say +1 and it accepts. If I store 1000 here, it will not accept because it does not fall in the range of 0 to 255 and hence it throws an error as well, right? So let me store something like 30 in unsigned integer 8. Same way, you can just create uint and this will mean a normal integer, unsigned integer power 256, right? So just like integers, unsigned integer also has a power of 256 bits, right? So let me call it E and then some number, right? Perfect. So this is about integers and unsigned integers. Yeah, wonderful. Let's get into the concept of strings. Okay. I told you that in other programming languages we have something called as character, right? And here in Solidity you don't have the concept of character. So what is this character first? When you want to store only one letter in the English alphabet into a particular storage location, you will use a character, usually denoted by char. But in string, string is a collection of characters, right? So when you take my name, RAGHU, that is 5 characters that comes together and forms a string, right? So to create a string in Solidity, you will do string, that is a keyword, and then say public, and let's call it name, right? I can just leave it that way, and the default for this string will be equal to nothing, right? And or you can assign some name to the string variable as well. So you can say foo. Remember that any string that you give in Solidity should be enclosed between double quotes. Only then the program understands that to be a string variable. Otherwise, if I remove the quotes, let's see what happens. It thinks that this Raghu is a variable, that's why it says undeclared identifier, right? It thinks it's something like A, B, C that we have declared, right? So that's the reason I give a double quote so that the compiler understands that it is a string, right? So that is about the string variable type. Next, going into the Boolean variable type. What is this Boolean all about? Boolean is a binary variable type which has true or false, present or absent, yes or no, 0 or 1 kind of things. So in the backend, it is stored as 0 and 1, but you can name it however you want. But usually, Solidity supports true and false. So let's say you want to take the attendance of a particular session, right? So you want to know if Raghu is present or absent. So you can say attendance as the variable and mark it to true or false, because you know that there are only two options available to store this, whether he is present or he is absent, right? So you don't need to store it in a string and say absent or present and make the memory a lot more, right? Instead, you can use a Boolean to say it is true or false. If it is true, he is present. If it is false, he is absent, right? One thing that we need to remember here on why we need to be so efficient when it comes to Solidity programming is that in other programming languages, even though there is an option to create integer 8 and integer 16 and everything, as a programmer, we do not care about it. We do not use it anywhere, right? Reason for that is in JavaScript or any other programming language, we don't have the need for this. When there is a whole lot range of, let's say 0 to a large number, let me use that, right? But when it comes to Solidity or any smart contracts running on a blockchain, you need to pay fees for that, right? Remember that anything that you do in a smart contract, you have to pay gas fee to the miner. Yeah. So when you try to pay gas fee for an integer 8, it is much lesser compared to int 16, which is much lesser compared to int 32, and int 256 carries a lot of gas fee that you need to pay. 1 byte of storage that you do in a Solidity programming language or in turn in Ethereum blockchain takes a lot of gas. 1 MB of storage if you want to do, it takes $4,000 approximately, going by the current price of Ethereum and current gas price, etc. Right? 1 byte of storage is 5 gas for you. Yeah. So imagine what will happen if you use all the inefficient kind of variable types. That's why be very careful. If you're sure that one of the variables will take only values between, let's say, minus 128 and 127, always use int 8. Don't ever go into integer variable type. Or if you're sure that it will contain only positive numbers from 0 to, let's say, 255, always use unsigned integer 8 instead of using uint just like that, because you might end up paying much more gas fees while deploying this contract into blockchain. So that is how Solidity in turn makes you as a very efficient programmer itself, right? So yeah, having said that, let's declare a Boolean variable for which bool is the keyword, and then let's call it public. Let me name it tf is equal to true or false, right? Anything. Now that is how you create a Boolean, and the default for Boolean is false, right? And default for integer is double quotes, which means there's nothing within that blank string, right? Default for integer, of course, is 0, right? So that is the Boolean variable type. Next comes our bytes variable type. Now, Solidity has a variable type called as bytes, which converts any string that you give into its hexadecimal format. So let's talk about bytes, right? And if you get into it, bytes also, just like integers, have how many bytes you are gonna put together. So it starts from bytes 1 and it goes from bytes 2, bytes 3, bytes 4, and the maximum is bytes 32. Or just like integers, you can denote it as bytes itself. So let's create a bytes variable, call it public visible, and you will say byte sample, right? Equal to, I'll give a normal string here called as ABC in small, and I'll create one more bytes, right, called as byte sample 2, and put it as ABC capital, right? We'll look at how this bytes variable looks, of course, but for now, know that each of the characters in the English language has a hexadecimal value associated with it. If you go to this particular sorry, if you go to this particular website called as ASCIItable.com, you can find that all of the characters that we know, all of the decimals and octa and character this way, has a hexadecimal value associated with it. So as I see here, I can look at it and say the capital A, as you can see here, A, B, C, D, E, F, that's the English language. So capital A can be converted into a decimal value of 65 or a hexadecimal value of 41, right? Same way, small a will be 61 as a hexadecimal value, B is 62, and go on, right? So what will this bytes do is convert A into 61, B into 62, C into 63, and store it as, right, store it as 0x, which is representation for hexadecimal, 61, 62, 63, right? Most of the time these bytes are used for comparing two strings, because you cannot compare two strings directly in Solidity. That's a small disadvantage, right? You can convert that into bytes and then compare it, right? So there's a lot of advantages of converting it into bytes. So this will be 42, 43, and 44, right? Oh, I think 41, right? Yeah, 41, sorry. So it will be 41, 42, 43, right? So this is how it will be stored internally when you declare a bytes variable here, right? So that is about bytes. Remember, it goes from bytes 1 to bytes 32, and if you just mention bytes, it means bytes 32, right? So that is the concept of our normal integer or string and boolean and bytes variable types. How to declare them and how to assign values to them is what we saw now. Let's get into the more complex variable types like arrays, enum, struct, mapping, etc. Okay. Now, getting into arrays and understanding why do we need arrays and in what situation will you use an array, right? So, let's consider the concept of classroom itself, right? So you have about 15 students who are sitting in a classroom, and you want to store all their names together. Okay, you can either do one thing called as, let's say, a string. Of course, names will be strings, right? String public student 1 is equal to, let's say, Raghu. String public student 2 is equal to John, whatever, right? You can keep on creating this kind of variables, 15 variables, S1, S2, S3, S4, etc. But that becomes very inefficient and you'll not be able to manage what you're doing itself, right? So for that, what we can do is use an array, which means an array is a combination of same type of data, right? Combination of same type of data. What do I mean by that? If you have multiple strings, all the students' names is going to be strings, right? So put all that together and store it in a single variable called as an array, right? How does this array concept work is, it will create this kind of a memory area where it will create multiple storage levels, and if it is a string array, one string will be stored here, the next string will be stored here, the next string will be stored here, and so on. So student 1 name can go here, student 2, student 3, etc. But all of it together can be called as students, and you can access this elements through a index, right? So arrays start with 0 index. So this will be 0, this will be 1, 2, 3, 4, and so on. So when you want, let's say, the name of the second student, S2, you need to say students of 1, because that's the second position, right, is equal to what? So in our scenario, I gave it as John, and this will be giving back John as the value. So this makes it far more easier for me to create a combination or a set of all the similar variable types together. So an example here shown is the string array type, or you can also have a integer array, right? So you can have multiple things like this and then say 0, 1, 2, let's say 15, 19, and everything. This probably can be used for marks of a student, right? All the students' marks you want to put together in an array, and you can create this way. This also is 0, 1, 2, and if you want to access the third variable here, then you will say marks of 2, right? So that will give you the third variable in this particular array, right? So that's the concept of arrays itself. Okay. How do you create an array? Is by a normal method of creating a string. Let's say I want to create students array as I showed you, right? I will create string public. I'll name this students, right? And this is how you create a string, a single string called as students. If you want to create multiple, students or an array of the student names, then you will use string and then square brackets. Open square bracket and close square bracket is what you'll use. This makes it a dynamic array. This makes it a dynamic array, right? Which means there is also something called as fixed array. So let's look at how fixed arrays work. Same case, string of 3 public students. Let's say students 2, right? So this is a static or fixed array, fixed length array, let's call it. What is the difference between these two is that in the second case of students 2, you know that there are only going to be a maximum of 3 students, right? Or let's say 15 students from our example. So you can only store maximum of 15 elements into this array, 15 names into this array, and it is a much more effective solution because the compiler easily understands, okay, I need to create 15 slots for you, right? On the other end, if you don't know how many people are going to attend something, let's say you are creating a webinar and many people are joining that, you want to store all of their names into the array. You don't know how many people are going to attend that, right? So you'll create something like a dynamic array. A dynamic array assigns the values as it comes. It does not assign it immediately as soon as you create. It will say, okay, let me understand, and whenever a new student comes in, let me add that string into this array. That way is how dynamic array works. Okay, so also remember that the concepts of, let's say, push, pop, length, all of these things work with arrays in Solidity also, right? So these are JavaScript concepts, and if you do not know that, we'll look at it when it comes to functions, right? Let me create one more array for integers, and a normal integer is created this way, sample int, let's call it. And if you want to convert this into a array, you will do open bracket and close bracket. I want to create it as a dynamic array itself, so let it be this way, right? Push, pop, length are possible in Solidity also, right? Wonderful. So this is the concept of arrays, and remember, array is the combination or a set of similar variable type data grouped together, right? So that's the concept of arrays. Next, we'll look at the concept of mapping and then go to enum and struct, right? What is this mapping all about? So I'm going to talk about mapping, and let's go to the board to understand more about what is this mapping all about. Now, whenever you are creating a programming language and things, you need to have a scenario where you can have keys and values, right? We usually call this key value pairs, right? So in your ID card, if you consider, right, in your ID card, it will say name of the employee, right? Let's say Raghu, right? And probably the employee ID, right? Employee ID is so and so, and let's say email, yeah. And you can also have the blood group, right? Usual things in the company ID card is these things. So what does this mean? Every ID card of the company employees will contain name, employee ID, email, and blood group, right? This is the key. Okay, this is the keys, right? This does not change. Okay, it remains constant for all of the people, but these values for each of the keys change, which means name has been mapped to Raghu for this particular employee. Employee ID has been mapped to Raghu for this particular employee alone, right? So keys to values mapping is what you are doing. Same way, in Solidity also you can create something like keys and values, right? You can say, let's say students are the keys. Student 1, student 2, student 3, student 4 are keys, let's say. And you can map this to anything you want. You can say true, right? True means this person has attended the class. So S1 true, S2 let's say false, right? S3 let's say is true again. What will this do? You can easily mark the attendance. You can say S1 true, S2 false, etc. Can you do this with arrays? Not possible, because arrays can only contain S1, S2, S3 and S4, right? Whereas mapping gives you a keys to values kind of a map, right? Match the following kind of stuff, and hence you can easily assign a value to each of the keys. Now, keys can be of any type, okay, any type, and values can be of any type as well. What does that mean? You can map a string to a string, right? String to a string. Let's say integer to a string, or in this case, a string to a Boolean, right? Or let's say a Boolean to an integer. Anything, any combination of keys to values is possible, right? One more big advantage of using this mapping is that all of the possible keys will be available in the mapping, right? I'll show you while giving you a demo of all the variables, right? For arrays, if you look at, let's say it contains 3 items, right? So it will have a memory location where it is 0, 1 and 2. So when I ask for the third element, okay, can you give me, let's say, names of 3, right? This will throw an error because there is nothing called as third element in this array, right? It's a dynamic array and it has not got the third element yet, and it will not give me anything. It's a error that is thrown out of this output. Now coming back to mapping, right? Let's say you are mapping integer 8 with booleans. Okay, of course boolean, as we know, is only true or false, right? That value you have to give. What happens here is integer 8, we know the range of it, right? Minus 128, minus 127, minus 126, and so on, right? Goes to 0 and keeps on going to 127. What happens when you do a mapping between integer 8 and boolean is that every possible thing within integer 8 will be assigned to the default value of the value, which means false. So it will all be false, right? It will all be false. Yeah. And whenever someone changes, okay, minus 127 to true, then this changes. Only this mapping changes. What does that mean? Whenever I am requesting something which I have not stored already, let's say I did not store anything for 0, right? So if I ask for what is the mapping of 0, it will give me false. It will not throw me an error, right? That is the advantage of using a mapping, where if you do not know who all are going to come for a particular party or a particular election or any application, right? Now you can use a mapping to mark their attendance, whether they have invested already, whether they have come already, kind of things, right? So if you know the people, if you know what you are going to store, then you can use this array. And if you want to check values which you have not stored till now, you will use a mapping. We'll see this in the demo, of course, right? But first we'll understand how to declare a mapping. Now, how to declare a mapping goes like our usual mapping keyword, right? And usually we'll do public and then let's say map. Yeah. So this is how you create a variable for a particular variable type. But in the case of mapping, we can give what should be the variable type of the key and what should be the variable type of the value also. And hence, you will give something like open bracket, close bracket. Within that, let me try to do the string to boolean itself. Okay. So I'm giving string gives boolean, or this equal to greater than will act as the mapping. You can remember it as string maps to boolean, that way, right? So this is one mapping that I have created. How to assign value to a mapping, we'll look at it when we go to functions, because we cannot do it outside a function, right? That is the concept of a mapping now. Remember, mapping is a key value pair, just like dictionaries in Python. If you know Python, you can compare that with dictionaries, where that is also a key value pair, right? That's the next concept. Now we'll enter into the enum, right? And then we are going to look at struct, and with that we'll complete the variables, of course, right? So what is this enum? Enum means enumeration. Okay. Enumeration, what is it? When do you use an enumeration? Is when you want to, let's say, two advantages. Okay, you want to save storage, okay, and confine options for users, right? So first thing, I'll explain how does it save storage, but first we'll look at confining options for users. What does that mean, right? So if you go to any website, I'll go to one of the websites that I know of which uses this concept, right? So okay, this is not working anymore. Let's go to apple.com, right? When you go to this, you can see that this has a drop down here, right? So when you click on this drop down, it's going to take you to all the countries that is available, right? So if you click on this, you will be able to find all of the options. Why are they giving you an option like this? Is because they want you to choose only the countries in which they are part of. They don't want you to choose a country which is not available in their list of countries that Apple is operating in, right? So they want you to choose this country only, right? And that is why enumerations are used. So enums are used to tell your user, see, you can choose only these options, right? Choose any one of this, correct? Or you can create your own variable type which maps to something like cities, where all your application or DApp is being used by and things. So with the probably explanation of how to create it, you will understand what we are gonna talk about, right? This enumeration is starting with enum as the keyword, right? And you will say the name of the enumeration itself. Let me call it cities because that's the example I'm going to take here. Open flower brackets and close flower brackets. Within these two, you will give the multiple options that you have. Let's talk about, let's say, Los Angeles, and we'll talk about California, and let's say San Jose, and let's say Toronto, right? So I'm telling my users that these are the 4 options that you can use, right? So if your user comes to your DApp, he has to see all these options and say, okay, these are the 4 options that I can choose as the city that I am living in. I cannot give something like Antarctica or Africa or India or Europe or something where we are not available, right? So only in these options you are available, and hence you will allow your users only to choose these 4 options, correct? That's how you confine options for all of your users, right? So this is how you will give a enum, right? One thing you need to note here is that you cannot give strings here, right? As you can see, you get an error whenever you give a string. Also, you cannot have a space in between. It does not allow that, right? So let me put it as San Jose and Los Angeles like this. So more than knowing how to do something, you should know how not to do something. That will make you a better programmer, right? So this is how you create a enum, okay? Now, okay, you have created this enum. What is the use of this? How does a user select this is my city, right? For that, we need to understand how this enum and structs and all the object-oriented concepts work. There are objects which you create, and there are instances for that object, right? Now, for example, okay, the integer and let's say unsigned integer, Boolean, these are all predefined variables created by Solidity itself for you, right? What does an integer 8 say? It has some rules, right? It has rules like it can be only between minus 128 to positive 127, right? That's the rule for integer 8. Unsigned integer 8 has rules which say, what are the rules of it? 0 to 255, right? These are the rules that has to be followed, right? Boolean says it should either be true or it should be false. That's the rules for the Boolean. These are all predefined variable types created by Ethereum itself. Now, using enum, right, or any other object-oriented programming concept, what we are doing is we are creating a custom variable type for ourselves. Means what? When I created the cities in Solidity, what did I do? I created rules, right? My own rules, which said the variable that you create can have only 4 options. Just like here, they can have only 256 options. I am saying it can only have 4 options: Los Angeles, California, San Jose, and Toronto, right? Now the user will be able to create variables based on these options only. In integer, what happens? This is a predefined rule, right? Now to create a variable for an integer 8, you will say int 8, which is the type that you have created. Then of course say public or whatever, and then say A or B or whatever, right? Similarly, if you compare this concept with cities, I can say cities public, call it as C1, right? This is how I create a new variable with my custom variable type that I created just now, right? So go through this concept again if you are not familiar with this, right? Now let's create a new variable for this cities. So I will say cities public C1 is equal to, right, cities dot let's say Los Angeles, right? So this is how you create a new variable. You have created a new variable type called as cities, confined the options to only these four, right? Whereas a string can have anything, right? But you don't want your users to give any string possible. So you want to confine them, and cities public C1 equal to cities dot Los Angeles. Right? So this is how you will create a new variable. You can keep on creating, right? You can just copy this and make it as C2, which is equal to let's say San Jose, right? Possible. Okay, you can keep on creating for each customer. Customer 1 city is Los Angeles, customer 2 city is San Jose, kind of, right? So that is the concept of enumeration. So we understood confining options for the users, how does it work, etc. Now we need to look at what is the saving the storage. As I told you already, if you want to store 1 byte of data in Solidity, you need to spend 5 gas, right? So storing strings is a costly affair whenever it comes to Solidity or any blockchain for that matter. Okay. So what happens in this case when you declare it as an enum is that this Los Angeles will be mapped to 0. Okay, the number 0. California will be mapped to the number 1. San Jose will be 2 and Toronto will be 3. So that is how this will be stored inside the blockchain and in the backend itself. And Enum converts the options into 0, 1, 2, 3 so that the storage is much more efficient, right? So it does not store strings like Los Angeles, etc. It only stores the mapping and says 0, 1, 2, 3, right? So when we get into the demo, you'll definitely get to understand that concept as well. Next, we are going to get into a struct concept. Now, to understand the concept of struct, which is also an object-oriented programming concept, we need to get into understanding what it is used for, right? Previously, we saw the concept of arrays, correct? Where you say student names, right? And let's say there are multiple student names like John, Alice, Bob, let's say Charlie, and a lot of people, right? So when you wanted to group all of these student names which are of the same type like string together, you used an array, correct? But in most of the cases in our daily lives, we need a table kind of a structure, right? You don't only want to store the student names, you want probably their roll number, and you want probably their attendance, and you want their mobile number, let's say, and email ID, right? Their balance or marks, let's call it. Okay. So this student names is a string, roll number will be an integer, attendance will be true or false, boolean, mobile number integer, email ID string, and marks will be integer. Which means what? You need to store multiple variable types together. And the variable type used to store this is called as a struct. Okay. So remember, similar data types together is called as an array, and multiple data types together is called as a struct, right? Here also it's the same scenario where first you will create the column headings. Okay, you will say my struct will contain student names, roll number, attendance, mobile, email, and marks. That will declare first, and then you will create the first instance. Raghu is having all these attributes. That will be one variable. Student 2 will be having all these attributes. That will be second variable kind of. We'll look at it in detail now. To create a struct, you need to start with the keyword called as struct. Let me call this as, let's say, students has been already declared. Let me use the capital, right? Student. Now I have to declare what each student has as a property, right? So I have string name as we saw in the Excel. Then I have to give, let's say, Boolean attendance. I'll also have a integer called as roll number. Then I will have something like integer marks, right? So these are the four things that I'm going to put together for each and every student. So I have created again my own variable type, which is a variable type called as student, and it has rules like it should have one string, it should have one boolean, it should have one roll number, and it should have one marks. All this together form a student. Just like minus 127 to positive minus 128 to positive 127 marks a integer 8. All this together will form a student is what I say created. Now let me create a new student also. Similar to the enum concept, you can say student public student1 and end it. So this student1 becomes a variable that is created under this variable type called as student. So you can go back, watch the video again if you do not understand the enum and student and creating our own variable types. But this is very important for you to understand the object creation and instance creation, right? Perfect. Now we have called all of the variable types: integer, string, booleans, bytes, arrays, enum, struct, mapping, etc. Now we will get to the advantage of this Remix IDE and look at what is the advantage that Remix gives us. I've spoken about it before, but we are going to see it live now. So when you get into this compiler, it just shows some warnings which we can ignore for now because we're in the beginning stages of understanding Solidity. And if you go to the deploy section, you can easily deploy your contract into the local blockchain instance and immediately get access to all of the variables that are there, right? So let me click on deploy and see what happens. Remember that there are 100 ethers in the first account given by this JavaScript Solidity simulation, right? Now, once I click on deploy, some amount will be cut from here as the gas fee, and the contract is going to be deployed into the local blockchain. Once it is deployed, I can immediately access the variables in the contract from here down below. When you have deployed contracts, you can access all of the variables that you have. We'll go one by one to understand what has been stored there. So the first one I created was in public A and I gave a value of 4. So if you do this, it will say integer 256 type and the value is 4. Then comes integer 8, b is equal to 10. So if I click on this, it will give me the value automatically like int 8 and 10, right? C is equal to 20. Let's go to this. C int 16 and 20, right? Then we created unsigned integers. So where are they? D and E, right? So D is uint 8, 30 and E is uint 256, 19. Then we stored a string called as name, right? So I'll click on this name to see the string type of Raghu, right? Then we created a boolean with tf equal to true, and when I click on tf, it gives me true. Then comes our bytes where ABC should be stored as 0x 61 62 63. Let's check that. Byte sample and byte sample 2. Byte sample, as I told you, is stored as 0x 61 62 63, which means the string that I gave has been converted into hexadecimal values. Byte sample 2 is 41 42 43 as we expected in hexadecimal format. Then comes the string array of students. So if I look at the students array, in here it asks for an input. What does it mean? Is that these Remix IDE and whatever variables we have cannot give out the entire array to you, right? So it will ask for an index. If you give an index, it is going to give you the value that is stored in that particular index, right? So when I give 0, right? When I give 0, it is not going to return anything to me. If you know why? Because I have just created an array or declared an array, but I have not stored anything into that, right? So I'll definitely show you by storing something how it works. But before that, if I take the 0th index of students, it's gonna give me an error. If you look at the log here, you can see that call to basics.students error. It is a invalid opcode because there is nothing in that storage area, right? Same goes for students 2 also, but students 2 is a fixed length array, which means what? I have already told my blockchain that I'm going to have 15 strings, okay, inside this array. So what my compiler will do is go to the storage and create 15 slots for this array especially, okay. Why can't it do that for students? Because it's a dynamic array. You can store one student name or you can store 100 students name. It cannot determine how many strings are going to be there. But in this case it can, and hence it will store all of it. Now if we go for 0th index of students 2, you can see that it gives me a value. and it is a blank string because everything will be default by when you are creating and declaring it, correct? So that's the concept of our dynamic array versus fixed length arrays. Of course, sample int also is not going to give us anything. It's going to give you an error because it's dynamic and we have not stored any value, invalid opcode, right? Now comes the interesting part of mapping. So let me go to this map, which is here, and I am saying string to Boolean. Have I changed any or have I stored any value here? No, right? But still, if I give my name, right, Raghu, and click on this map, it is giving me false, because remember that keys will take all the possible values of that variable type and assign it to the default value of values, right? So the default value for the values, which is Boolean here, is false. So all the strings in the entire world will be assigned to false now. Not only Raghu, I can give something like, let's say, Donald Trump, right? And see the mapping, it is also false, right? Or I can give something like Barack Obama, right? And this is also false. Michael Jackson, anything, any name that you want to give, any string also. Just like that, I can type a random string, and if I check that, it is going to give it return false, no errors, because all the possibilities of string are there inside the mapping, right? That's the beauty of using a mapping in Solidity. Then we'll look at enum cities, which is stored in these two variables. Let's look at C1. And if you think C1 is going to hold Los Angeles, then you are mistaken, right? Because C1 stores 0 as the value. As I told you, this first value will be assigned to 0. This will be 1, 2, and 3, right? So it is much more efficient to store it in an enum because this is not stored as a string, but it is stored as just 0. And if you look at this, this will be 0, 1, and 2, right? So the C2 will, which is San Jose, is be stored as 2, right? So that's the concept behind this enum itself. And now you understand how it is saving some storage for us. The last one, we'll look at the struct called as student, where string name, attendance, roll number, marks, all of this will be stored, right? And student 1 has just been declared. We didn't assign any value, but you can go to the student 1 to see that it contains 4 fields: name, attendance, roll number, and marks. Name has a default value of blank string, so it is not giving anything. Attendance is a boolean, so blank is false. Roll number is an integer, marks is an integer, so the default is 0. That's what has been stored in student 1. Whenever I assign values to each of these fields, it will get assigned to the particular field itself of the student. That is how you create and see what is happening to your variables within Remix IDE. We have understood how to create variables and how to see them in live action using the Remix IDE also. So as the last step, let me create a dummy students list just so that we can see how this returns the value, right? So sample integer, let's create 1, 2, 3, 4, right? Now deploy it again and access this. I'll just go to students and sample int directly. If I go to students and click on 0, previously we got an error because nothing was stored in the first position. Now if I click on this, it is going to return the first element I stored in this array. Same way, 1 is the second element, right? Sample integer, if I go to, I can give 0 and it's going to return 1. That's the first element, right? So if you give 2 or 3, let's say, it's going to give the fourth element, right? But if you give 4, which is the fifth element, it's going to throw an error. So here you can see that it has thrown an error because there is no fifth element in this dynamic array, right? So these are the concepts of variables. In the next video, we'll get into the functions to understand how to manipulate these variables and change the values and make it do whatever you want to do. Let's see in the next section.